Hello, am I audible? Can anyone please confirm whether am I audible or not? Okay, thank you. So, yeah, good evening everyone. I am Riya Takwal. I am doing PhD at IIT Kharagpur under the supervision of Professor Sudeep Mishra. And so, someone has asked a question that can you once show the code working of Python conversion of RGB to black and white image? So, in the previous set of slides also that part is given. So this is the code for converting your black and white images into for converting your colored images into black and white images. So for that, first of all you have to import the PIL library, and after that you have to upload the image. So whatever be the image, you will upload that or open that image. So this im.show will show the image that you have uploaded. Now in order to convert that image from color to black and white, this L is the mode of black and white, so you have to write im.convert L. Okay, so im will denote your image, so it is going to convert to black and white. After that, you are once again you are going to show the converted image, And if you want to save, you can use this command, that is gray image dot save, and whatever name you want to give, you have to put in the brackets. So this will be the output for this. So for example, if this was the image that was uploaded, then it is the black and white image of that particular. Is it fine? Screen not visible. Oh, wait. Okay. Now is it visible? Please unmute and say it's difficult for me. Is it visible now or not? Okay. Yeah, so question was that Python code for converting your colored image into black and white image. So this is the snippet for the same. So first of all, you have to import the library, that is PAL. From PAL you have to import image library. Then you have to open that particular image which you want to convert to black and white. So this is the path of the image. Then if you want to show that colored image, then this is the command im.show. Then in order to convert, you have to write this line, that is im.convert, and this is the mode. So L basically means black and white. Now gray image dot show will show the gray image, and after that if you want to save that particular image, you have to write this. So this is the output of that particular snippet which I have shown to you. So this is the code. Now let's move to week 7. So yeah, last week we discussed about socket programming, how your two devices can interconnect with each other and transmit messages. So basically, whenever you are going to use socket programming, first of all you have to declare the descriptor of socket on both the machines. Your one machine is client, your one machine will act as client, and your other machine will act as server. So at the server side, you have to bind your machine with a particular IP address and a particular port, and after that, with the help of those IP addresses and port, your client device is going to connect with your server, and once the connection is established, you can transmit the message to and fro from the client to the server and server to the client. And once your task is completed, you have to close the session. So now today we will continue with that part only. First of all, we will discuss about remote data logging. So basically, okay, your sensors are basically collecting the data, your internet of things, what they are doing. So they are basically creating an interactive environment and sensing whatever is taking place in the environment, right? So once that data is sensed, you have to send that data from the sensors to one particular device where some analytics can be performed, right? So And so for performing that analytics, you need to store the data at a particular device. So remote data logging means collect the data from the devices in the network, send the data to the server or remote machines, and then control the network remotely with the help of this the various kinds of command and analytics which we have performed. So the system overview is the network of temperature and humidity sensor is considered in this figure. So now whatever data your sensor will generate, you have to send the data to the server and save the data at the server. So in order to do that, what you require is you require some sensor, that is your DHT sensor, then resistor, jumper wire and Raspberry Pi in order to make the connection. So in we have already discussed in one of the session that how your sensor can be integrated with your Raspberry Pi. Okay, so this thing we have already done, that how your sensor can be integrated to your Raspberry Pi. So this system, that your sensor system will become a client. Now you have to send that data from Raspberry Pi to some machine where some analytics can be performed, right? So one system will be your sensor and Raspberry Pi, and other system can be your Raspberry Pi or your computer or your laptop, anything. Yeah, so this is the DHT sensor. We have already discussed that there are 4 pins in case of DHT sensor. Pin 1 is for power supply, pin 2 is for data, pin 3 is null, and pin 4 is ground. Now, yeah, this is the connection establishment between the Raspberry Pi and your DHT sensor. So basically you have to connect pin 1 of DHT sensor to 3.3 volt pin of Raspberry Pi, then pin 2 because pin 1 is for power, pin 2 you have to put it to any of the input pin of the Raspberry Pi. For example, here we have taken it as 11. Then you have to connect the pin 4 of DHT sensor to the ground pin of your Raspberry Pi. In this way the connection establishment is done. Then after that your Adafruit library is used if you want to work with your DHT22 sensor. So you have to first of all install the library in the Raspberry Pi. We have already shown that how you are going to install the library. You have to go to the tools, and from there you have to add the particular library you want to add. Now you have to use the function, that is adafruit underscore dht dot read underscore retry in order to read the data from the sensor. So this is the code. So this part is your you are just collecting the data. Now you need to send the data to some remote machine, right? So sending the data to the server. So for sending the data to the server, here comes the concept of socket programming, because in the last session we have already discussed that how socket programming can be used in order to make communication possible between two different devices. So now here the devices will be, one will be your Raspberry Pi and other will be your other can be your laptop or other Raspberry Pi or computer. So your socket programming creates a two-way communication between two nodes in a network. The nodes are termed as server and client. Server perform task or services which are requested by the client. Now sending the data to the server using various network protocols. So you can use either TCP or UDP. So accordingly you have to declare that which kind of protocol you are going to use whenever you are creating descriptor of socket. Then establish a connection between the server and client and then send the data. So this is the syntax of defining a socket. uh, so here in the bracket you have to write the socket family, then the type of socket you are going to use, and protocol. So basically protocol by default is set as 0, and socket family can be AF Unix or AF INET. So these are the types of the addresses which you are going to use, and socket type is the type of protocol which you are using. For example, if you want to establish TCP connection, then the type of socket will be sock stream, and if you are going to establish UDP connection, then the type of socket will be sock dgram. Yeah. So once your data will be sent to your remote device, now you have to store the data in such a manner that the important information can be fetched from that particular machine, or some visualization can be done on the data so that it is user friendly. Okay, so for example, you are sending some sensor data to your remote machine. Now what to do with that data? Either the end user should be able to know with the help of graphs that how the values of your humidity or temperature are varying, or the data format which you are using to send, it should be user friendly, right? So in that case you have to either split the data, because the data which your sensor will send is continuous range of continuous stream of data, right? Now you have to split the data in order to make that to make it as useful information, and after that you have to plot the data. Now for data splitting and filtering, so for example, basically consider this, that if your data is Sunday, Monday, Tuesday, okay, so this is separated by comma only. So you have stored this in your doc file or somewhere, right? So in order to make this data as an useful information, you have to split, because so first value should be your Sunday, second value should be your Monday, and third value should be your Tuesday. So for that you can use data splitting. So this can be so this is the syntax of splitting. So basically split function can be used in order to split a string into multiple strings depending on the type of separator or delimiter specified. So basically in the split function you have to mention that which kind of separator you are using. So in this case the delimiter is your comma. So for example, data dot split. Now inside the split function you have to mention the separator you are using. So it can be hash, it can be dollar sign, anything. Now once you have fetched the important information from the data, you have to make that data in a you have to show that data in a user friendly manner. So for that you have to plot the data. So in order to plot the data, Python provide a library, that is your matplotlib, in order to plot 2D graphs. Inside your matplotlib there are various functions which you can use in order to plot graphs. So plot can be used. So inside the plot you have to mention the values of x and y, that how your graph will move. And in order to give the labels to your axis, x label and y label can be used. So if for example you want to write y-axis on your you want to write distance on your y-axis. So here you have inside this commas you have to write distance. And if you want to write like speed in your x level, then inside this comma you have to write the speed. Now this figure is for this snippet. So first of all you are importing the library, that is your matplotlib. After that whatever you want to plot, you are using myplot.plot the data. And now on the y-axis the label is y-axis, so here you can see. And on the x-axis we don't put anything, so there is nothing here. Now in order to show the plot, show function is used, that is myplot.show. Now there are various other functions which are used and which are present in your matplotlib library. So first one is your figure. So it creates which is used for creating new figure. Then grid. So in order to enable or disable grids in the plot, you can use this function grid. So if you are using grid enable, so here lines will be there, so which will show the grids. Then iron, so it will turn on the interactive mode. Then subplot, for adding a subplot in your figure. Then close, for closing the current window. And for generating the scatter plot, you can use function, that is scatter. Okay, so this is for remote logging of your data. Now the next topic which we will discuss is SDN. So so in your traditional network what happened is, so if you want to send data from your sender to receiver, there are various intermediate routers and switches, right, through which your data will travel. Now consider, for example, this is the case, right? User 1 want to send data to user 2. Now there are various intermediate devices through which the data will travel. Now so various kinds of protocols can be used in order to send the data. For example, in this figure 2, OSPF protocol is used. So it can be any protocol which will show that which route has been taken by your data. Then in case of traditional network, if your particular switch or if your particular router has been attacked or become corrupted, then you need to make the changes or need to find the alternate path in order to send the data. Now what is the problem? So in order to find the alternate path, you have to make changes in the network, right? So in traditional network, since it is distributed, you have to write 1000 lines of codes or very big code in order to make the changes. So this problem can be solved if there is some central controller which is going to control the complete network. So if there is some central controller, you are going to make changes there only. You don't have to make changes in your complete network to change the route. So limitations of the current network. So basically vendor specific architecture of switches limits the dynamic configuration according to application specific requirement. Switches are required to configure according to installed operating system, and centralized control is not feasible in traditional network. After that, yeah, see this figure. Okay, so basically whenever there is if a particular router or switch become corrupted, you have to make changes in your network. You have to write 1,000 line of codes which will make this routing mobility management difficult. It will also be cost expensive, and also different gates will be, or millions of gates, you have to make changes over these gates. Now the solution for this is, as I have told, that if there is some central controller. So what SDN is? So in case of SDN, your traditional at the traditional network, uh, only the data forwarding or data plane is there. There is one central controller which is control plane, which will decide that which routing path should be taken, and if a particular switch will get affected, then all the details will be stored in your control plane only. So that you have to make changes only in that control plane, and with the help of that control plane only you can control the entire network. So this is showing that the hardware part is your data plane, where with the help, which can only forward the data, and all the decisions or all the decision making process are taken place at your control plane. So this green, that is your operating system and application layer. So this is your control plane. Now origin of a software defined network. So basically in 2006 at Stanford University, a team proposes a clean slate security architecture, that is SANE, to control security policies in a centralized manner instead of doing it at edges. In 2008, the idea of software defined networking is originated from OpenFlow project, and this work was published in ACM SIGCOMM. Then in 2009, Stanford publishes OpenFlow version 1. So basically this OpenFlow is a protocol which is used in SDN. So this is the algorithm which is used in SDN in order to forward the data. Then in 2009, Nikera network is found, and then in 2011, Open Networking Foundation is formed, and then in October 2011 only first Open Networking Summit happened, and many industries took part in that, and they proposed this idea. So basically this figure is showing the architecture of SDN. So basically for forwarding the data, your data plane is there. So hardware part is present in this data plane. Now there is one controller which is your control plane, which is going to control all the switches which are present in the network. And after that in application plane, so with the help of this application plane, this complete network can interact with user. Now basic concept of software defined networking. So separate control logic from the hardware switches. It
एक्सक्यूज मी
defines,
मैम,
yeah.
मैं मैम प्रीवियस फिगर में ऑपरेटिंग सिस्टम कहाँ पर होगा?
Operating system is at this control plane. So basically this is the hardware part which is just sending the data. Okay, so that is your data plane, and the controller system will contain your OS, and application layer is the other layer. So basically this control plane is your network operating system. Yeah. So separate control logic will be there in case of SDN from the hardware switches. It defines the control logic in a centralized manner. It controls the entire network including individual switches. The communication between the application control and data planes are done with the help of APIs. So basically there are mainly two types of API, that is northbound bound API and southbound APIs, which make the communication between these different planes possible. Now the current status of SDN. So basically various companies such as Google have started to implement SDN at their data center networks. It is required to change the current network with SDN in a phased manner. Operational cost and delay caused due to link failure can be significantly minimized. Now the components of SDN. So first component is your hardware switches, which are responsible for only transmitting the data or forwarding the data. Then second one is a controller, which is going to control the entire network. And then the application with the help of which you can interact with the network. Then flow rules. Flow rules are the rules which will decide which path to follow. And after that, application programming interfaces, that is APIs. So these are of two types, southbound and northbound. These make communication possible between your different planes, that is your application plane, control plane and data plane. Now the challenges. So first challenge is rule placement. So rule placement means, now a rule means that which path to follow. So that will define your rule. Now your controller will contain all the rules. So at the switches they are going to send some rules only which are used at a regular interval of time, right? Now which rules you have to place at your switches, so deciding that thing is one of the major challenge. So it is similar to your caching only, so which data to store at the near to the end user. So basically that is the same case, that which rule to place at the hardware. The second one is controller placement. Now controller placement means that where exactly to place the controller, because there are number of devices, right? So there might be a case that your controller is near to only 3 or 4 hardware devices. So these hardware devices can easily interact with the controller, but the other devices which are far away from the controller, it becomes difficult for them these devices to interact with the controller. So how to place the controller so that this exchange of rules between your controller and your switches can take place easily. Yeah, so yeah, rule placement. So switch forward traffic based on a rule which is called your flow rule, defined by the centralized controller. traditionally routing table in every switch is maintained. So every switch or router are maintain routing table in case of your traditional network. Here in case of your SDN, flow table is maintained at every switch, and inside your flow table only few rules are stored. All the rules are stored at the controller, and at the flow table few rules are stored. So which rule to store at your flow table, this is one of the major challenge. Yeah, so the size of TCAM, that is your ternary content addressable memory, so these switches use TCAM memory, is very limited. So the number of rules which can be stored or inserted is less. Fast processing is done using TCAM at switches, that's why TCAM is used at switches, and also TCAM is very cost expensive. The other challenge is on receiving a request for which no flow rule is present in the switch send a packet in message to the controller. So basically if a particular rule is not present at a switch, right? So that switch is not able to decide that where exactly to send the data. Now for example, data is coming to a switch from an unknown sender right? So for that data, your switch is unable to decide what to do with that data. So for that, since your controller has the idea of complete network, it has to interact with the controller. It has to get the flow rule from the controller. So for getting the flow rule, it sends packet in message to the controller. The controller decides a suitable flow rule for the request, and the flow rule is inserted at the switch. Now typically 3 to 5 millisecond delay is involved in new flow rule in new rule placement. Yeah, so the challenges are how to define or place the rules at switches while considering the available TCAM, since the TCAM memory is very limited, and which rule you want to place at your switches, this is one of the problem. How to define rules so that the number of packet in message are sent to the controller are less. Okay, so these are the two major issues. First one is which rule to place, second one is which rule to place so that the exchange of messages is very less. Yeah, so now open flow protocol. So open flow protocol is a protocol which will decide that which rule to place at your flow table and which not. So it has different versions, that is 1.0, 1.1, 1.2, 1.3 and number of. So the match fields of a flow table um, varies, depending upon the versions which you are using. So different match fields that can be used are your source IP, destination IP, source port, priority, destination port. So these fields depend upon the version which you are going to use. Now in case of your open flow protocol, two types of timeouts are used. First one is your hard timeout and second one is your soft timeout. So hard timeout means the all the rules which are present in the flow table are deleted after a particular interval of time in order to reset the switch. Okay, and soft timeout is if no flow rule is received associated with a particular if no flow is received associated with the particular rule, Then after a particular amount of time, you are going to delete that particular rule from the flow table. So this is soft timeout. So basically timeout will tell that after what amount of time you are going to delete the rules from your flow table. So hard timeout, at hard timeout, consider that the hard timeout is 30 minutes. So after every 30 minutes, all the rules which are stored at your flow table will be deleted. And soft timeout means if a particular flow is not utilized since long, so you are going to delete that particular rule. Now there might be a case that people think that SDN is a open flow, but no, SDN is a concept and open flow is a protocol which you are using in your SDN in order to make the communication possible between your data plane and control plane. So there might be other protocols also which can be used for this purpose, but OpenFlow is the only protocol which are present till date, which are practically used basically. So now OpenFlow switch software. So these are various switch softwares. So first one is Indigo, then Link, then Pentao, Off13 soft switch, then Open vSwitch. So these are different kind of your switch softwares. Now the APIs which are used in SDN. So first one is your southbound API. So southbound API is used to communicate between the control layer and the infrastructure layer. So OpenFlow protocol is basically used in your southbound API. The second one is your northbound API. So it is used to communicate between the controller layer and the application layer. Standard APIs are used here in order to make this communication possible. And the next type of API is your east-westbound API. So it is used to make the communication possible between different controllers in the control layer. So there might be a case that there is not only a single controller which is controlling the entire network. So there might be 2 controller, 3 controller, depending upon the need or depending upon the network architecture which you are using. So making the communication possible between 2 different controller, the APIs which are used are called your east-westbound APIs. After that, the second challenge was controller placement. So controller define flow rule according to the application specific requirement. The controllers must be able to handle all incoming requests from switches. Rule should be placed without incurring much delay. Typically, a controller can handle 200 requests in a second. The controller are logically connected to the switches in one hop distance. Physically, they are connected to switches in a multi-hop distance also. If we have a very small number of controllers for a large network, the network might be congested with control packets. So yeah, basically if you have large network and you are using only one controller or few number of controllers, then those controllers are not able to handle or control the entire network. So in that case, your network will congested with the packet in messages. Now different types of architecture that can be used in your SDN. So first one is your flat architecture. So in case of flat architecture, for every device, for every physical device, that is your for every physical switch, there is one controller, right? So here, as you can see, that there are three physical switches, and for each of these switch we have one controller. So this particular controller is controlling only this switch. So all the flow rules related to this particular switch are stored in your this controller. For this stored in this, and for this this controller is going to store. The second one is your tree architecture. So in case of tree architecture, there are few switches which are handled by a particular controller. There are few others which are handled by another controller, and there is one main controller which is going to handle the subcontrollers. So in the form of tree, the controlling of different devices take place. Then mesh. So in case of mesh, there can be different number of controllers present in your network, and these controller can control any device which are present, or any switch which is present in the network. Then ring. In case of ring architecture, there are various controllers present in the network, and logically one by one these controllers are going to control the switch which are present in the network. Now control mechanism. So control mechanism can either be distributed or centralized. So the control decisions can be taken. If the control decisions are taken in distributed manner, then it will be a distributed, and if it is taken in a centralized manner, then it is a centralized control mechanism. Now in SDN, there is one type of controller which is called your backup controller. So if your main controller is down, then what is going to happen? Then how your switches are going to forward the data? So in that case we need some backup, right? So we put so in that case we put some other controller, or we use some other controller which is your backup controller. So this backup controller is just the replica of the actual controller, and it is going to get activated only when your main controller is down. So if the main controller is down, backup controller control the network to have uninterrupted network management. Now security in SDN. So for ensuring security, you can use firewall, proxy, HTTPS, or intrusion detection system. Then different simulator or emulator which you can use in order to implement your OpenFlow or SDN. These simulator or emulator must support OpenFlow protocol. Then the controller placement which you are going to do must support OpenFlow protocol. And remote controller can be situated in a remote place and communicated using IP address and port number. Then Minnet is one of the simulator with the help of which you can implement your SDN. So it is used to create a virtual network with OpenFlow enabled switches. It is based on Python language. It supports remote and local controller. Now controller configuration software. So these are the different controller configuration software which are available. So first one is POX, Knox, Floodlight, Open Daylight, ONOS. Now the IoT architecture. So basically
मैम एक छोटा सा डाउट था, जो स्विच होता है
हाँ,
स्विच है उससे आप सिर्फ कंट्रोलर को कनेक्ट करते हो या स्विच से और आईओटी डिवाइसेस भी कनेक्ट हो सकते हैं?
स्विच से बेसिकली स्विच इज ओनली फॉर ट्रांसफरिंग द डेटा. इट्स नॉट लाइक कि
उससे मल्टीपल स्विच भी कनेक्ट हो सकता है, मतलब एक स्विच से और भी मल्टीपल स्विच कनेक्ट हो सकते हैं?
हाँ. See, because multiple switch, there should be a connection between multiple switch. That's why they can send the data to another switch, right? If there is no connection between two switches, then how your switch is going to forward the data? For example, यहाँ पे in the mesh architecture you can see this particular switch is connected to this switch also, this switch also, so it is communicating with these switches also, right? So you can connect. Yeah, now IoT architecture. So here two different models are used in order to show your IoT architecture. So in first model, that is given by IoT World Forum, it is your IoT World Forum reference model. So according to this model, there are 7 layers. So first layer is your physical device layer where your IoT devices are there. So after that, your connectivity layer is responsible for connecting these IoT devices. Then edge computing layer, so some basic functionalities which can be done at near to your IoT devices. So this is your edge computing layer. Then data accumulation layer, so this layer is responsible for storing the data which is generated by your IoT devices. Then data abstraction layer, this is responsible for the aggregation of data and access. Then application layer, so with the help of application layer, your end user can interact with these other layers. And then collaboration and processes. So basically collaboration and processes means the people who are going to use the data which is generated by your this IoT devices. So the one other kind of architecture is this one. So according to this architecture, there are mainly 3 tiers. So first one is your context aware tier, then second is your network tier, and third one is your application tier. Inside your context aware tier, there are your data collector, that is your IoT devices, and your coordination and collaboration take place. Collaboration and coordination means how your different IoT devices are going to interact with other, how the coordination can take place. So this is the second layer which is present in your basically inside your context aware tier only there are 2 sub layers. Now network layer is responsible for establishing the network connection, how your data will get transferred. So this layer is responsible for that. And then your application layer. So application tier contains 3 sub layers. First one is your intelligent computer technology, which is responsible for doing some analytics. Then middleware layer, so for management purpose, your middleware layer is responsible. And for making the interaction possible between the end user and the network, your application layer is responsible.
मैम नेटवर्क लेयर में भी डेटा जो है वो पैकेट के फॉर्म में ट्रैवल होता है या किसी और फॉर्म में होता है?
हाँ, पैकेट, सो बेसिकली इट विल डिपेंड अपॉन, हाँ, पैकेट्स की फॉर्म में, दैट इज द सिंपल नेटवर्क विच यू आर यूजिंग. So
डेटा
data,
पैकेट के फॉर्म में।
right, right, right. So now the benefits of integrating SDN in IoT. So first one is intelligent routing decisions can be deployed using SDN, because there is one single controller where you can easily deploy intelligent routing decisions. Then simplification of information collection, analysis and decision making. After that, third benefit is visibility of network resources. So network management with the help of SDN become easy, because as you know that if there is only a single centralized system, then management will be easy. Then intelligent traffic pattern analysis and coordinated decisions can be done in your SDN. Now at different layers of your IoT architecture, how SDN can be implemented. So at your lower layer where your IoT devices are there, you basically this is responsible for sending the data, and your SDN is responsible for taking the data from these devices and transmitting to some other devices. Now at the second layer, that consists of your various kind of mobile stations where intelligent aggregation is done, your rule placement at the access devices can be done there. Third one, where transport network is there in your traditional network, rule placement and traffic and engineering at the backbone networks can be done, and flow classification and enhanced security at data centers can be done at your cloud. Now the challenges of integrating SDN in IoT. So first challenge is real-time programming of sensor nodes. So you have to program your sensor node according to the SDN. So real-time programming is one of the challenge. Vendor specific architecture. So each of the switch have vendor specific architecture. So the interoperability issue is there. Resource constraint, heavy computation cannot be performed, so these devices are resource constrained. Limited memory, cannot insert too many control programs there. Now the opportunities of integrating SDN in IoT. So first one is, can we program the sensor node in real time? So basically whatever be the challenge are the opportunities. So in order to resolve the challenge, that is the opportunity only. Second one is, can we change the forwarding path in real time? Can we integrate different sensor nodes in WSN? Now this is a paper, that is your sensor open flow, which is given by Low et al. So here value centric data forwarding is done with the help of your SDN. It forward the sense data if exceeds a certain value, and ID centric data forwarding is basically two type of forwarding is done in case of your sensor open flow. First one is your value centric and second one is your ID centric. So in case of your value centric, forward the sense data if exceeds a certain value, and ID centric will be there if it forward the sense data based on the ID of the source node. The other work which is done in SDN is soft WSN, which is done by Bera et al. So they propose a sensor device management system where multiple sensors can be implemented in a single sensor board. Sensor can be used depending upon the application specific requirement. Delay for sensing can be changed dynamically in real time using your SDN, and active sleep management of different states, that is your active and sleep modes, can be changed dynamically. So if you want to get more idea about this work, you can go through this paper. So first one is your sensor open flow by Luo et al, and second one is your software WSN by Bera et al. So these are some results of soft WSN. Now questions, but before questions let's take a break of 5 minutes, and after that we will start. So this is the link I have shared in the chat box. I have uploaded the PDF to the drive, and this is the drive link. let's start with the questions. So question number 1 is, in socket programming, the parameter AFINET stands for week 8 material will be available on next week. Yeah, question is, in socket programming, the parameter AFINET stands for, options are Unix protocol, internet protocol, file sharing, time slicing.
Internet protocol.
Internet protocol. Okay, anyone else? Yeah, so correct option for this is internet protocol. Next question is, during remote server access by Raspberry Pi, where the Raspberry Pi acts as a client, the client needs the following. Options are only IP address of server, only port number, both server IP address and port number, client IP address.
Both server IP address and port number.
Okay. Anyone else? So correct option for this is C. So whenever you are going to make a connection, you need both server IP address and port number for establishing the connection. Next question is, if you are using Raspberry Pi to connect IoT sensors such as your DHT temperature sensor, which of the following Python library lets you configure the sensor and read the data from them? Options are Adafruit, Matplotlib, NumPy, Socket.
NumPy, ma'am.
NumPy.
It's Adafruit.
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 A option Adafruit.
Okay, anyone else? Yeah, so correct option for this is Adafruit. Next question is, you can store and log the different sensor data for processing in text files but not comma separated value files. True or false?
Ma'am, true.
True. Anyone else?
It's option
True, ma'am.
false.
True. Ma'am, false.
False. True. Okay. So correct option for this is false. Sorry. The sensor data can be logged in any form. So it should be false. I have wrongly mentioned here as true. So you can use either a CSV file or text file in order to store your sensor data. So it's not like you can only use text data or your CSV file in order to store. So it should be false. Next question is, consider the following Python script using the split function. What will be the correct print output? So there is one variable which store a string apple comma guava hash banana. Then var is equal to
Option D.
option D, apple guava in banana. So basically here the splitter is hash. So it is going to divide or split this into two parts. So first one will be your apple,
It's
guava,
option
and
B,
then banana.
apple and
So
guava.
right,
Option B.
option is D. Right. Next question is, in SDN the central controller define all the paths, flows and behavior of the
Can you
network in
explain the previous question? Fifth question.
what, repeat please.
Fifth question.
Okay, how, why it is D? Okay.
Yeah.
So basically here there is one variable which is storing a string, that is apple comma guava hash banana. Now this split function is going to define the splitter or the separator. So according to this, hash is the separator. So whenever hash will be there in your string, it is going to divide that particular string into two parts. So first part will be your apple guava. So right, apple guava will be the first part, and after this banana will be in the second part. So here this comma will, so first entity is this apple guava and second entity is banana. Okay, so basically according to A there are three entities, apple, guava, banana, but in the question only hash is the separator. So there should be only two entities, one before this hash value and one after the hash value. So D is the appropriate answer. Yeah. So question number 6 is, in SDN the central controller define all the paths, flows and behavior of the network in centralized manner. True or false?
True. False.
False.
Someone is asking question. Which of the following is a property of relay? Mechanical switch, electrochemical switch, none of these, all of these. So correct answer is D, that is all of these. Relays, please refer. So
I have a doubt, but in the option C we are having none of this. Then how it will be all of this? That was my doubt.
so this is for the questions which I have given, or in your
No, it was there in the assignment, week 6 assignment.
okay. So I'll ask the TAs, because these things I don't handle. I only give you the previous year questions.
Okay,
So
okay.
I'll let them know. I'll take the screenshot of this and let them know.
Because I have gone through the video lecture also, there it is mentioned like it's mechanical switch and electromechanical switch.
Right.
But here it is given electrochemical switch.
Okay. So
So that's why.
you can ask this question on the discussion forum also, because through that only you can interact with
Yeah.
your TAs, right? But
In the discussion
I'll
forum
let
because
them
of
know.
the timing.
I will let them know, and accordingly
Okay.
you will get the answer.
Okay, okay. Thank you.
Yeah. So question was, in SDN the central controller define all the paths, flows and behaviors of the network in centralized manner. True or false?
False.
False. Anyone else?
False.
Okay.
True.
Okay, those who are saying false, why it is false, and those who are saying true, why it is true.
मैम ट्रू इसलिए क्योंकि जो आपने अभी थोड़ी देर पहले एक वो दिखाया था ना डायग्राम जिसमें मैश था और सेंट्रलाइज टोपोलॉजी से सब थी, तो उसमें ये साफ साफ क्लियरिटी के साथ दिख रहा था कि बात कैसे फ्लो हो रहा
Okay.
है सेंट्रलाइज के साथ. दैट्स व्हाई आई एम गोइंग टू से विद दैट ट्रू.
Okay. So those who are saying false.
मैम सेंट्रल कंट्रोल डिफाइंड पाथ को फॉलो नहीं करता है ना, सो इट इज फॉल्स.
No, what? Repeat, please. So correct option for this is true. So basically the definition of controller in case of SDN is that it is going to manage all the flows or paths in a centralized manner. अभी जो मैंने डायग्राम दिखाया था, in that diagram there might be either 2 controllers or 3 controllers, but अगर in a network there are 2 or 3 controller, can you say it is distributed network? No. Distributed means anyone can enter in that network, anyone can participate, anyone can start controlling, right? So that is the mechanism with the help of which they are going to control the network. So distributed mechanism means there can be different controllers which are present in the network, either 2 or 3 depending upon the need, but at the end there will be some centralized set of controllers which are going to control the entire network. So if there are 10 or if there are 100 also, there are some set of centralized controller which are going to handle the entire network, right? So this statement is true. Next question is, OpenFlow is a protocol that is used for traditional distributed OSPF based networking. Anyone?
मैम OSP का फुल फॉर्म क्या है? OSPF.
Ma'am, it's false.
It's false. Open shortest path, F say I have to check. Anyone who knows the full form of OSPF?
Open shortest path forwarding.
F से क्या है?
I'm not sure. Forwarding.
Forwarding. हाँ, I guess it is true. Open shortest path forwarding. I'll check and let you know. But you try to answer this question. It's open shortest path first. So it is a protocol which is used in your traditional network, which will tell how to forward the data basically. It is open shortest path first. So question is, OpenFlow is a protocol that is used for traditional distributed OSPF based networking. True or false?
False.
Anyone else? No? Yeah, this statement is false. Next question is, in SDN, blank tables in switches describe the rules that the switch must follow for packet forwarding and are configured by the controller. Options are
Flow table.
network, distance, hop, flow.
Flow.
Flow. Okay, anyone else?
Flow, ma'am.
Option B, flow table.
Option D.
D, flow.
Right, option D is correct. Flow tables are maintained at the switches. Next question is, in a network architecture, one logical hop between two nodes can actually be composed of multiple physical hops in a physical network. Options are true or false.
Option A, true.
Okay, anyone else? Yeah, this statement is true. Logically, there should be one hop and physically it can be multiple. What among the following is a challenge while designing SDN architecture? Options are A. Control placement only, B. Both rule and control placement, C. Rule placement only, D. Switch placement.
Ma'am, both.
It's option B, both rule and control placement.
Correct. Option B is correct. Both rule and control placement. Next question is, packet type of messages are associated with which of the following directional APIs? Options are eastbound APIs, southbound API, westbound API, northbound API.
Ma'am, southbound.
Okay.
Yeah, southbound, option B.
Right, southbound API, because southbound APIs are responsible for the interaction between your data plane and your controller, and these packet-in messages also exchanged between your switches and your controller. So southbound APIs.
और मैम इसमें सिर्फ 3 ही एपीआई थे ना, चौथा तो था ही नहीं।
क्या हुआ?
हमने यहाँ पे 3 ही, हमने मैम यहाँ पे 3 ही एपीआई पढ़ा था ना,
हाँ
चौथा तो है ही नकली है चौथा।
हाँ हाँ, C and D are incorrect because no, A and C are incorrect basically. It's east westbound APIs is single one only. Next question is, for an SDN switch flow rule, the soft timeout is set to 2 minutes and hard timeout is set to 6 minutes. After 6 minutes and 10 seconds since the flow rule was initiated, what will be the status of flow be in the switch? Options are, the flow will be surely deleted, the flow will be deleted if it receives no packet for 4 minutes, the flow will remain intact, the flow will remain intact with random probability.
It's option A, the flow will be surely deleted.
Ma'am, option A.
Option A. Anyone else? Yeah, option A is correct because hard timeout is
Because after in hard timeout we are resetting the switch.
yeah. So in the question it is given as hard timeout is 6 minutes. So after 6 minutes your switch will be reset. So basically all the flow rules which are stored will be deleted. Next question is, it is a good idea to keep a backup controller in an SDN architecture along with the main controller. True or false?
It's true.
Option A, true.
Option A, true. Anyone else? Right, it's true. Next question is, software defined IoT solves the challenge of blank that is relevant uh, in the traditional IoT networks. Options are uniformity, deployment, homogeneity, heterogeneity. Anyone?
Option D, heterogeneity.
Anyone else?
Option D.
A. Uniformity. Anyone else? It's heterogeneity because every switch is vendor specific. It is difficult to achieve interoperability, right? So it's heterogeneity. Next question is, sensor open flow, soft WSN and SDN vibes are example of blank. Traditional routing protocol, various SDN protocols for wired LAN, various implementation of the concept of software defined IoT, traditional IoT protocol example.
Option C.
It's option B, various SDN protocols for wired LAN.
Option C,
Option
software defined IoT.
Right, option C is correct. So basically these are the implementations of SDN which are developed for IoT. Next question is, you have an IoT temperature sensor that is sensing temperature from a particular location and sending the data over the network to a server situated far away in another city for storage. This is an example of remote data logging. True or false?
It's option A, true.
Anyone else?
Option A, true.
Right, this statement is correct. So option A is correct. Next question is, for a two-way communication between a client and server, that is both the client and server send data to each other, it is important that both of them knows about the following about each other. Options are only IP address, only port number, both IP and port, neither IP and port. Same question and before.
And option C, both
Option
IP
C.
address and
Both the IP address.
Right. Both IP address and port number are required. Next question is, if you are using Raspberry Pi to connect standard IoT sensors such as DHT, which among the following component of Raspberry Pi do you use to connect your Pi to your sensor for data transfer? A is HDMI port of RPi, micro SD card slot in RPi, Ethernet LAN port of RPI, GPIO pins of RPI. Anyone?
option D, IP.
Option
C, ma'am.
C. Okay.
GPI वाला।
GPIO D. Anyone else? Correct option is D. In the starting of this session only, I have told you that how the connections can be established. So basically, you have to connect your the pins of your sensors to the GPIO pins of your Raspberry Pi. For example, in the example which I have shown, the pin is 11, right? So it can be anything. So GPIO pin is correct. Next question is, it is possible to connect a single DHT temperature sensor with a suitable number of connection wires with two Raspberry Pi acting as a client for the same sensor. True or false? Anyone?
True.
True. Anyone else? This statement is true. So you can connect any number of Raspberry Pi to same sensor. Next question is, which among the following denote the correct connection order of standard 4-pin DHT sensor with order pin number taken as 4321? So options are data null ground par, B is ground data par null, C is ground null par, data par, D is par data null ground.
ऑप्शन सी मैम।
Option D.
Okay. Okay. Pin 1 is for par, pin 2 is for data, 3 for null, and 4 for ground. So option C is correct. Next question is, using the library in Python, you are plotting a graph of pressure values versus time, with pressure taken in the vertical axis and time taken in the horizontal axis. While writing the code to plot the graph, which among the following is correct parameter denoted by question mark that you can write within the function y-level brackets? Options are time, pressure, length, mass.
When pressure.
Pressure. Okay, anyone else? Yes, pressure is correct because vertical axis is pressure and by y-level denotes vertical axis. So correct option for this is pressure. Next question is, lack of centralized control is a problem and limitation of traditional network architecture without software defined networking support. True or false? Anyone?
True.
True. Okay, anyone else? Right, this statement is true because there is no centralized control, so it becomes difficult to manage large network in your traditional network architectures. Next question is, Detaching the physical hardware from the overlying software components such as operating system and application forms an important aspect of transitioning to SDN. True or false? A. That is true. Anyone else? Yes, this statement is true. Next question is, flow rules are stored within SDN switches that run the open flow protocol in the following format. Okay, format is options are images, file, tables, none of these.
Tables.
Tables, right. Next question is, among the following, which is the most unlikely to be considered as suitable candidate for match field for flow rules in SDN? Options are source port number of the packet, destination IP address of the packet, temperature of the switch motherboard, destination MAC address.
Option C, ma'am. Temperature of the switch motherboard.
Okay, anyone else? Right, option C is correct. So basically, whenever you are going to make a flow table, what why your temperature of the switch motherboard is required there, right? So for making the flow table, the incoming address or the outgoing address of two devices are required. Next question is, in SDN, the central controller of one network can communicate with the central controller of another SDN network through which of the following directional APIs? Options are east to west wound API, south wound API, west wound API, none of these.
West.
East to west. Okay. Anyone else? Right, it's east-west API. So with the help of this east-west API, different controllers can interact with each other. Next question is, suppose question is, suppose in SDN there are two switches S1 and S2. The same packet P arrives in both the switches. S2 does not have appropriate flow rule to forward this particular packet, whereas S1 has. This is with respect to two switches. What is the correct action that is taken? A is S1 sends packet into controller, S2 forwards the packet. B is S2 sends packet into controller, S1 forwards the packet. C is both S1 and S2 send packet into controller. D is both S1 and S2 forward the packet. Anyone?
Option B.
D. Okay.
Option B, ma'am.
Option B. Okay. Anyone else? Yeah, correct option is B. That is S2 sends the packet into the controller because it does not have the information, and S1 forwards the packet. Next question is, no matter how big an SDN network becomes, we can never have more than one SDN controller. True or false? we have more than one?
False. False.
Right. This statement is false because we can have many controllers. Next question is, with software defined IoT, is it possible to control the individual physical sensor and actuator nodes as well as rule placement of the backbone network remotely by suitable orchestration and software? Yes or no? Anyone?
Yes, ma'am.
Anyone else? Yes, yes is correct option for this question. Next question is, soft WSN that has been proposed as one of the solution to software defined IoT achieves the following: only device management, only topology management, both device and topology management, neither device nor topology management. Anyone? So it is used for achieving both device and topology management. Next question is, the switches in a non-software defined network environment do not have global view of the network. True or false?
True.
True. Anyone else?
False, ma'am.
False. Okay, anyone else? This statement is true. So they don't have the global view of the network. So it is achieved with the help of controller when you are going to use SDN. However, in case of traditional network, the complete view of the network is not there. Next question is, which of the following is not a function of application plane in software defined network architecture? Options are business logic implementation, security, traffic engineering, forwarding. Anyone?
Option D.
Option D, forwarding.
Option D, ma'am. Forward.
Yes, option D is correct. Next question is, in socket programming, this is repeated. Parameter AF-INET stands for Unix protocol, IP protocol, file sharing, time slicing.
Ma'am, IP. This is a repeat question.
Right, IP. Next, I guess these all are repeated. No, this one is different. Controllers in SDN receive requests from the options are end user, gateways, switches, routers.
Switches.
Right, switches is correct. So switches basically send requests to the controllers in order to get the flow rules. Next question is, during remote server access using socket programming, what is the utility of socket name.listen function? Options are to create a new socket, to bind the socket to the connection, to wait for client to connect to close the connection.
A, ma'am.
What? These different function I have discussed in the previous session.
Yes, ma'am. It's C.
C, to wait for the clients to connect. Okay, anyone else? Yeah, it's C. So basically, listen means your server is listening to all the active connections which are present in the network. So it wait for the clients to connect. Next question is, with respect to client server model of socket programming, in which of the following does the function socket name dot bind reside? Options are client, server, both client and server, non-client and server. So
Option B, server, ma'am.
server, bind is used at server. Okay, anyone else? Right, server is correct, because in case of at your server device you have to assign some IP address and port number. So basically, in order to bind your machine with that particular port number and your IP address, this bind function is used. Next question is, which among the following are valid data processing activities? Options are data splitting, data filtering, data plotting, all of these.
All of these.
Okay, anyone else?
All of these.
Right, all of these are correct. Next question is, which among the following is correct direction for packet-in type messages in SDN? Options are from controller to switch, from switch to controller, between two switches, between two controllers.
Switch to controller.
Switch to controller. Yes, switch to controller is correct. Basically, packet-in message means the request messages which are sent by your switches to the controller to get the flow rules. Next question is, suppose a particular flow rule has soft timeout of 5 seconds and hard timeout of 3 seconds. Is this association correct? Yes or no?
No, ma'am. Option B.
No.
Right. Option B is correct, because your hard timeout should be greater than your soft timeout. Otherwise, after every 3 seconds, your switch will get reset and there is no need to do soft timeout. Next question
अगर
is,
मैम अगर प्रीवियस क्वेश्चन में अगर स्वैप कर देते 3 की जगह 5 और 5 की जगह 3
हाँ,
तो वो करेक्ट हो
that
जाता.
will be correct, right. Next question is, in SDN backup controller are required for which among the following? Options are to act as backup of the main controller all the time, to act as backup when the main controller fails, to replace the main controller altogether, none of the above.
Option B, ma'am.
Option B. Okay, anyone else? Right, option B is true. Backup controller means which is going to take the control whenever your main controller fails. Next question is, which of the following is true? So traditional network maintain routing table, SDN maintain routing table. B is traditional maintain flow table, SDN maintain routing table. C is traditional maintain routing and SDN maintain flow. D is traditional maintain flow table and SDN maintain flow table. Anyone? This is very easy.
And C option.
C, right. In case of your traditional network, Different routers maintain routing tables. However, in case of your software defined networking, your switches maintain flow tables. So option C is correct. Next question is, what are the benefits of using SDN over IoT? Options are management of device heterogeneity, management of end device mobility and dynamic flow rules, software control of end devices, that is sensor and actuator, all of the above.
All of these.
All of them.
Right, all of the above is correct. Next question is, sensor open flow soft WSN. This is repeated question, so skipping this question. Okay, and this is also repeated. I guess all these are repeated. Yeah. The next question is, with software defined IoT, it is possible to control the individual physical sensor and actuator nodes as well as rule placement of backbone network remotely by suitable orchestration and software. Yes or no?
No, ma'am. Option B.
Okay, anyone else?
Yes.
Yes. Anyone else? Yes, this statement is correct. Next question is, consider that only following match field based flow rule is installed within open flow enabled SDN switch and no other flow rules are present. So this is the flow rule. Okay, ingress port is 90, source IP is given, egress port is given as 100. Means that if a packet with source IP address this, that is 10.15.16.20, arrives at port number 90, then the switch should forward it to port number 100. Now a packet with source IP address 10.56.78.100 arrives at port number 40. Which among the following is correct? Switch drops the packet, switch send packet in message to the controller, switch forward the packet to port number 100, switch forward the packet to port number 90.
Option B, switch send packet in message
Right,
to
right.
controller. ये ऑप्शन ये
Right.
रिपीट भी है शायद.
Option B is correct. Next question is, which of the following best determines SDN controller switch architecture? Centralized, decentralized, distributed, does not matter. Anyone?
Centralized.
Right, centralized is correct. Next question is, what nature of decisions are enabled on integrating SDN with IoT? Options are centralized, coordinated, distributed, decentralized.
Option A, ma'am. Centralized.
Option A. Anyone else? Yeah, option A is correct. Next question is, what is the full form of TCAM in SDN switches? Options are temporary content addressable memory, transmission content addressable memory, transfer content addressable memory, ternary content addressable memory.
Ternary.
Yes, D is correct. Yeah, so these were other questions? So those who have joined late, I'm giving you the link again. So this is the link of the Google Drive. I have already uploaded the PDF here. You can check whether you are able to access the PDF or not. Any topic which you want me to cover in the next session, or anything which you want me to discuss in the next session? If no, then I'm
Raspberry Pi. Ma'am, Raspberry Pi.
Okay, Raspberry Pi. Okay, fine. Anything else? Okay. Fine, then we will discuss Raspberry Pi in the next session, and all the topics which will be covered in week 8, and after that we will discuss some questions. So yeah, so those who have joined late, this is the link of Google Drive. I have already uploaded the PDF. Okay, and yeah, you can access the PDFs from this link.
मैम
Yeah.
मैम आपने वो कोड जो इमेज कन्वर्टर वाला होता है, आपने एक कभी मतलब आपने अपने कंप्यूटर में रन करके देखा है?
नहीं, मैंने ट्राई तो नहीं किया. आई हैव टेकन दैट फ्रॉम द लेक्चर्स ओनली. इज
मैं
इट
ट्राई
नॉट
किया
वर्किंग?
नहीं.
क्या एरर आ रहा है?
इमेज लाइब्रेरी कह रहे हैं ना, जो इमेज लाइब्रेरी है,
हाँ.
मतलब import PIL,
हम्म.
तो वो इमेज लाइब्रेरी कह नहीं रहा है, मतलब एक्सेप्ट नहीं कर रहा कि ये लाइब्रेरी है.
ओके, देयर माइट बी केस कि जो पाइथन का वर्जन तुम यूज़ कर रहे हो उसमें दैट इज़ डिप्रिशिएटेड. सो PIL की जगह यू कैन यूज़ पिलो लाइब्रेरी. ओके, सो
कैपिटल में PILLO लिखो.
हाँ. सो ये वाला केस जो है दैट इज़ बिकॉज ऑफ योर पाइथन इज़ नॉट सपोर्टिंग दैट पर्टिकुलर लाइब्रेरी. Anything else? No? Okay, then I am terminating the session. We will meet again on next Tuesday. Okay, thank you.
Thank you, ma'am.